Good morning, students. Today we are going to discuss about the PCBs, printed circuit boards. This is the subtopic in the third chapter in the subject of basics of electrical and electronics engineering. Our subject code is 18EI 105C. So first we are going to know what we are know after completion of this topic. Today we are going to discuss about what is a PCB, advantages of PCB, types of PCBs, types of laminates used in the PCBs, methods of layout preparations for making PCBs, methods of transferring layout onto the copper clad sheet, the steps involved in screen printing for making the PCBs. These are our objective of this class. So now first of all we need to know what is the PCB. Why we need the PCB? PCBs are very important in the electronic module designing. PCB, printed circuit boards, these are the boards already the paths, already circuit connections are printed on the circuit. The PCB is nothing but a piece of an insulating material which is made from epoxy or bakelite material. On this material or on this PCB, on this a layout of an electronic circuit consisting of copper or silver conducting paths are printed. This is called as a PCB, printed circuit board. This is the directly ready to connect the components for our required circuit. So generally you see this diagram, if you connect the components by using the wires, how it is. You see the wires is there, zigzag is there, one wire is connected with other. We can't use this because it is not a proper structure. It may lose its components, it may break its component frequently. So after that we having the another one, that is a breadboard connection. You see this is a breadboard. Breadboard is the device which is used for the temporary connection of the electronic circuit. We temporarily connect the components on the breadboard and test whether we are getting our required output or not on the breadboard. So breadboard is a temporary device or temporary platform. We can't use permanently. So for the permanently, if you wanted to design a same circuit in multiple ways, we need a permanent circuit. The circuit should having the permanent paths, permanent connections, and all should be on the permanent way. So that is called as the printed circuit board. The printed circuit board having a permanent layout for a particular circuit design. It provides all the circuit paths. On the paths we connect our required components for our application purpose. So what is the advantage of PCB? Why we are using these PCBs? The advantage of the PCB or printed circuit board is these are the small in size. Small in size means we don't having the zigzag structure. Okay, we need not to think about the connections. This is a particular device or particular platform permanently used for the circuit. It avoids long wires and cross connections. we does not having the wires and long connections, directly having the permanent paths in the board, so it avoids long wires and cross connections. And the PCB is easy location of faults, where we have getting the faults. If you take the wire connection, we can't identify where the wire connection is missed, but in the PCB we can check whether where that location, where the error is coming, where the fault is coming. The cost of the PCB is very less, and the designing also simple. For the designing we have the different methods are there. We make the PCB designing very simple. We can save the time. You can save the time and possibility of mass production. We can produce n number of devices or n number of boards for a particular circuit very easily. So the production should also be uniform production. Why? Because this is just like the Xerox copy of the one circuit. So one is there, the automatically we can get the Xerox of that printed circuit boards, n number of printed circuit boards. So it makes the advantage is the production is very rapidly increases, the fault should be reduced, and the cost should be reduced. The weight also it reduces, and the production is uniform. Now we try to discuss about the classification of PCBs. PCBs are classified so many ways. Now we try to discuss some of the methods. The PCBs are based on the type of circuit we are using. What type of circuit we are using, based on that PCBs are classified. The first one is the digital circuit. If the components or the connections are digital, that circuit board is called as the digital circuit board. If the components and the connection and the signals are analog, that circuit is called as the analog printed circuit board. Sometimes we may having the mixed analog and digital circuit boards are laid, just like the computer motherboard. In the computer motherboard we having the digital circuit as well as analog circuits also. This is the one of the classification. Now we can try to see how it is. Analog power supply PCB. Here you see all are the analog devices are there. There are no digital circuits are there. Digital circuit means we may have the integrated circuit. Digital ICs are there. No digital ICs are connected is there. So only the analog components are there. That's why it is called as an analog circuit board. You can see analog and digital. In this you can see the microcontroller, the chip is there, and another different chips are there. So these are the digital devices. So and another capacitor, all those are the analog devices. So that's why it is called as a mixed analog and digital printed circuit board. You can see in the diagram. So another classification is the PCBs based on type of components used and how they are mounted. What type of components we are using, how we are mounting on the PCB. Based on that we having the another classification is there. That classification is through hole. Through hole means the component mounting is through the hole, that is called as the through hole. Surface mount, if the mounting is on the surface, that is called as a surface mount. Mixed technology, if it may having the through hole and the surface, that is called as a mixed technology. And the other components mounted on one side or both side. If the components mounted on the one side, single side PCB, we can say that. If it is the both side, it is called as the both side PCB, that is called as a double side PCB. Double side PCB. Another classification of PCBs are based on the board construction. how the board is, that is a single sided board, double sided board, or multi-layer board, flexible board, or rigid or flexible board. Like this, we having another classification. Single sided means the board connections, whatever it may be, one side are there and the components mounted on the another side. Double sided means component mounted both the sides and the connections also both the sides. Multi-layer means here we having the two or three more layers are on the for the connection of components is there, that is called as the multi-layer. Some of the boards are the flexible printed circuit board. The means flexible means it may having the flexible for the extension of some more other components, it may having the, or rigid means it is for the fixed components. A rigid flexible means it may having the some sort of flexibility is there for the components. This is another classification of the PCBs. We also so many types of classification is there. One of the type is based on application and performance we required. What type of application we needed, what type of performance you need. Based on that we having the PCB classifications are there. Those are general purpose printed circuit boards, high performance PCBs, dedicated service PCBs, high reliability products. We having some of the classification is there. General purpose PCB means general purpose with having with no layouts on the PCB. We having the a common connection is there, common mounting is there. So using that type of is called as the general purpose PCBs, high performance and dedicated service and the high reliable products are there. So another type of classification of the PCB is, you can see the another type of classification is based on design complexity, circuit density and manufacturability. On this also we having the classification is there. That classification is low design complexity, low circuit density, low manufacturability, and moderate or high. Based on this also we having the classification is there. So now we can see single sided PCB how it is. That is a reason you can see the diagram. One side we having the components, another side we having the copper track is there. You can see copper track, holes for leads from components, rigid insulating material. Whatever the holes are there, from the holes we can having the leads of the component. This is called as the single sided PCB. The one example you can see how it is the classification and how it is the single sided PCB. It has copper plated layer on one side only. The conducting tracks and circuit layout is on one side only. The thing is copper plated layer one side and the conducting tracks and circuit layouts on the one side. That type of circuit is called as a single side PCB. You can see the double sided PCB. Here we having the both the side we having the copper tracking is there. Both side we having this one. You can see rigid insulating material, copper track, copper plate through hole. You can see the what we double sided PCB have. Double sided PCB have. In these PCBs, the two sides of the base material will be coated with the copper. The tracks are formed on both sides of laminate. Interconnection from one side to another side is done by the means of plated through holes. So both side we can use, both sides copper material is there, both side we having the copper tracks are there, both side we can connect the components and we can interconnect both sides also. That is called as a double sided PCB. You can see the diagram is there in the on one side, another side also we having the same type of the PCB. This is about the basic designing and basic classification of the printed circuit boards. So in the main printed circuit boards, what type of platform we are using, on the platform what type of materials we are using, how we are making the conducting path, how we are making the component holes for the connection for the leads, for the components, what we are making, how we are designing the a complex circuit or a simple circuit on a particular board. So that is we are going to discuss on the next slide. Now we are going to discuss about the laminates. You know that laminates are nothing but a platform on which we provide the different copper cladding or copper tracks. Those are called as a laminates. So many types of laminates are there. Now we try to discuss which type of laminate is useful and which having the advantage and which having some disadvantages. What are the uh, differences in the laminates? The base materials used for the PCBs are paper phenolic laminates or glass epoxy paper, polyester, etc. we are used as a laminates. Generally, the PCBs are built on a variety of substances. The particular substrate used for particular application is chosen on the basis of the function, operating environment, and the cost. So depending on these functions, we are going to design the PCB. We are going to design the PCB. So generally we can say the laminates, that is nothing but the base, the platform of the substances are called as the laminates. These laminates we may have the different types for the particular application and the particular functioning and for the particular operating environment and for the particular cost we use the different materials for the different material as the laminates. Example we having the some of the laminates. You can see the different types of laminates. You can see the one of the laminate substances is phenolic laminates, epoxy laminates, polyester laminates, dialiphthalate laminates, Fitfi laminates, silicon laminates, melamine laminates, polyimide laminates. These are the different types of laminates. Now, briefly try to understand what are the advantages, what are the disadvantages of these different laminates. Phenolic laminates. You can see the phenolic laminates. For the understanding purpose, you try to listen these things. Phenolic resins are reinforced with paper filter for copper clad laminates. They are light or dark brown in color. Whatever the PCBs are there which are having the dark brown or light brown color are called as a phenolic laminates. So phenolic laminates advantages are, the main advantage is the stable under a variety of conditions. The meaning is any different conditions, environment conditions, we can use the phenolic laminates. The cost of the phenolic laminates are low and easy to punch and fabricate. The main thing is we try to make the punches on the board. That comfort is more in the phenolic laminates. By this we can use the phenolic laminates generally. So what are the disadvantages for this type of laminates? The disadvantage is the main disadvantage is poor arc resistance and moisture resistance property is poorer. Moisture resistance is the important one. Why? Because if the moisture resistance is very low, the it may having the short circuit may occur on the board. So these are the two disadvantages. Depending on our requirement, we choose the phenolic laminates. Another type of laminates are the epoxy laminates. So these are the another type of laminates. Generally these are two types. First one is the epoxy paper, epoxy glass. The epoxy paper means the substrate is in the type of the paper type, and the glass means that is the form in the form of the glass type. The paper filler is a impregnated with epoxy resin. So what are the epoxy is a epoxy laminates means that is a sub part of a color we using that one. The what type of advantages for these type of epoxy laminates? The good electrical properties, it having the some of the advantages. Good electrical properties, high alkali resistance, tougher than phenolic and polyester. The thickness and the stability and the viability of this epoxy laminates are tougher compared with the phenolic and polyester. The thing is, we having the different types of laminates, that is the substrate to design the PCBs are there. Depending on our requirement, we choose these laminates. We are discussing the different laminates, advantages, disadvantages. We are using epoxy laminates. So what about these disadvantages? The disadvantage of the epoxy laminates are glass epoxy laminates are not suitable for punching operation. This is the main disadvantages. We having the paper and glass epoxy laminates are there. Paper with the paper laminates no problem, but with the glass epoxy laminates we having the punching problem is there. It may the circuit may breaks is there. Another laminate is the polyester laminates. This is the another type of laminate. The polyester laminates are solutions of unsaturated polyester resins in copolymer sable monomers such as terran, etc. So these are the some mixtures of these materials. Unsaturated polyester resins we are using for the laminates. So what is the advantage of the polyester laminates are exclusively used with glass fiber reinforcement, and the polyester laminate possesses good arc track resistance. Their physical stability and water resistance are also good. Because of these three advantages, we are using the polyester laminates. What are the disadvantages of the polyester laminates? These polyester laminates are not in extensive use in electronic industries, since epoxies can often supply better dielectric properties compared to the polyester. Epoxy laminates supplies the better dielectric properties. That's why we are using the epoxy one. We don't mostly use the polyester laminates. Another type of laminates are dialiphthalate laminates. These are glass reinforced laminates. The advantages of these laminates are exclusively used as insulation in electronics. These type of laminates are used in the Installation of the electronics wherever we require, we use this type of laminates. The cost of the laminates are low and also usable up to maximum temperature limit of 165 degrees centigrade. Until 165 degrees centigrade we can use this type of laminates. Another one, PTFE laminates are polytetrafluoroethylene is a thermoplastic when reinforced with glass results in a laminate with low dielectric constant and a low dispersion factor. This is the one type of laminates PTFE, that is the polytetrafluoroethylene laminates. So advantage of these laminates are low dielectric constant and a low dissipation factor under a wide temperature, humidity and frequency range. Electric strength is very high. Excellent electrical insulation under severe environmental conditions. Used for very high frequency and microwave applications. High insulation resistance under humid conditions. That's why we are using the polytetrafluoroethylene laminates very frequently. Disadvantage of these are the high costs rule out their widespread use. Because of the very high cost, we don't use this type of laminate frequently. So another laminate is the silicon laminates. We know that these are made of silicon resins with glass reinforcement. Silicon resins contain silicon, carbon, oxygen and hydrogen. So this is the silicon laminate. The advantages of silicon laminates are glass-based laminates have excellent arc resistance, good electrical properties up to 250 degrees centigrade. The meaning is arc resistance is excellent and also it can used at the high temperature, that is about up to 250 degrees centigrade we can use this one. So that's why we are using the silicon laminates. The disadvantage is do not possess characteristics of strength at any temperature. They don't having the characteristics of strength. The laminate does not have that one, so we don't use the generally. Mechanical properties are not superior compared to phenolics and epoxies. The mechanical properties also not good. That's why we don't use the silicon laminates frequently. Another one is the melamine laminates. You can know that the melamine laminates can be combined with a variety of reinforcing fillers, but best properties result when glass fabric is used. When gas fabric is used. The advantages of melamine laminates are it having the high arc resistance. The disadvantages of laminates are the poor dimensional stability. Dimensional stability is poor. That's why it is difficult to get higher mechanical strength. So these are the different types of laminates we are using for the printed circuit board. The choosing of the laminates depends on the environment which we are using, application which we are using. These are the different types of laminates. Now we are going to discuss about the layout preparation, how we prepare the layout. So what is the meaning of the layout preparation? Generally for any structure, any building, we need to have a layout. That layout gives the skeleton structure for the particular designing. So now we try to discuss about the layout preparation for the PCB. The layout of a PCB is the pencil sketched component and conductor drawing on a white paper or graph sheet is called as the layout preparation. This is it has to incorporate all the information such as size of circuit, track position and pad size, input and output connections of the circuit. This is called as the layout preparation. What are the rules for the conditioning of the layout? These are the general consideration and rules for the layout designing. The first one is mechanical consideration. Mechanical considerations are size, shape, mounting of the PCBs, etc. These are called as a mechanical considerations. Next one is the user system consideration. What does consumer for the consumer or laboratory or the industry? So this is for the user system considerations. That is what type of system we are going to design, that is like for the consumer purpose or laboratory purpose, industry purpose. The another consideration is electrical and electronic parameters such as impedance, gain, electromagnetic coupling, etc. Depending on this, we try to design the layout. We need to consider these things. Easy of maintenance. The maintenance should be easy. Basic methods of preparing the artwork, that is the layout. The basic methods are, you can see some of the methods are there. Now we can see the method. First method is the ink drawing. Ink drawing method is there. We try to discuss later briefly about these methods. The next one is the black taping on transparent base foils. Black taping on transparent base foils. Red and blue taping. Black taping on diazo films. And cut and strip artwork. These are the 5 methods we are going to discuss. In any method we can design the layout depending on our application, our understanding, our usability. We can change the designing. The first one method is the ink drawing. What is the ink drawing? The circumferences of the solder pads and the center holes are drawn with a drawing compass, and the space in between is filled with ink, are called as a ink drawing. Generally, the beginning method is the ink drawing method. Whatever the circumferences of the solder pads and the holes centers are drawn with the compass of, and the space is between these are filled with the inks, are called as a ink drawing. What are the advantages of this type of ink drawing? Are the advantages are is easy to draw with the hands. The difficulties or disadvantages of this ink drawing is difficulties in pattern rectification or modification. If we once design the design, modification or rectification is not possible in the ink designing. The erase operation will cause a rough surface where later on the lines can become smeared or ragged. So that is the main difficulty of the ink drawing. So another type of layout drawings are the block taping on transparent base foils. Block taping on transparent base foils. This is widely accepted as an industrial standard. With availability of self-adhesive tapes, pads, the artwork designed has become simple and more efficient. These pads are two types: self adhesive pads, and another one is the transfer pads are there in the back block taping on transparent base foils method. So in the self adhesive pads we having these pads are supplied with sticking on a backing paper. This pad is peeled from the backing paper and positioned where required and then slightly pressed so that it will adhesive to the particular board. If position of pad is to be shifted, it can be peeled off again, placed in the position required and pressed firmly again. That's why it is called as the adhesive pads. Another one is the transfer pads. The transfer pads, this is another type of pad. These are printed on a thin adhesive film of 10 micrometer thickness. This film is mounted on the carrier strip. The pad can be transferred from carrier strip onto the artwork by rubbing with a wooden stick on the carrier strip while the pad is exactly positioned on the artwork base. The carrier strip can thereafter be lifted from the artwork, leaving behind the pad. That's why it is called as a transfer pads. Whatever the artwork is there, that is on the pads are there. After that, that is transferred on the remaining pads. So this is another type of pads are there. Another type of method, another type of layout designing method is there. The next method is the tapes. The tapes method, you can see the tapes. These are supplied in rolls. These tapes are supplied in the rolls. They use very flexible, non-transparent materials. These tapes permits artwork with bends, corners and rounds. All these are possible in the tapes. These are available in the standard widths of 0.5 mm, 1 mm, 2 mm, 4 mm, 8 mm. So this is another type of layout method. You can see how they are. Soldier pads are there, integrated circuit pads are there, connector pads are there, tapes we having the other pads also, transistor dimensioning. These are the different types of layout methods we having the another layout method is base foil method. The base foils are made of polyester films. The surface may be matte or glossy. After completing the artwork on the base foil, the outline of the PCBs are identified by suitable corner making with 1 mm tape. These tapes are fixed outside the actual PCB area. The round bent corners are accomplished with black tapes. So that is the base foil method. Another one is the red or blue taping on transparent base foil. In this method, complete artwork of double-sided PCBs can be generated on only one base foil. It is the most convenient method for double PCBs with respect to artwork generation. What we are going to do in the red blue taping is the component pads which have to appear on both sides of the PCBs are generated by using the black pads. The conductor pattern is done with red transparent tapes for one conductor side and with blue transparent tapes for the other conductor side. Like this, by using the red blue taping, we can differentiate both sides and we can design the both side PCB by using the red blue taping. Special filters are used in producing the two film masters. A red filter put before camera lens will filter off the red taped conductors, while only the blue taper and black pattern will appear. A blue filter will filter out the blue taped conductor, leaving only the red taper and black pattern visible. The limitations of the red blue taping is the red blue taper cannot be stretched and cannot be used to make round corners as needed. We can't get the stretching and round corners. Two different types of film materials for the film master productions we can use the. It is more expensive compared to the simple taping. Another type of taping is the block taping on Dijo films. Dijo film is basically a polyester based regeographic film. Its emulsion is sensitive in the blue, violet, ultraviolet range. It is developed in a ammonia vapor. It is supplied in size of 1.505 millimeter width and 10 millimeter length with different thicknesses. We are using the black taping. The principle is an artwork of the pattern common to both PCB sides is made in block and polyester foil, whichever is the common that is in the block form. Two copies of this common layer are made by contact copying on the Dizo film. The respective conductor patterns are there after taped on these copies. Advantages of these films are no water is involved in processing, therefore no changes occur with respect to dimensions. The copy is immediately ready for further use after the development. Instead of the taped artwork, Dijo contact copies can be stored. Another artwork is cut and strip artwork. This method depends on the use of a single foil consisting of polyester film base of thickness of 100 to 125 micrometers with a red coating. The red coating has only little adhesion to the base and is cut through by means of a knife blade. That's why it is called as a cut and strip artwork. It can then be peeled off, leaving the negative pattern behind on the transparent base. The artwork is done on a 1:1 scale. The advantages of the strip artwork is as artwork is done at a 1:1 scale, it is directly used as a master. So this is the layout artwork, how we make the layout in different ways. We may having the different layout methods are there. Those are now we discussed about the basic method of preparing the artwork by using the ink drawing, and what are the disadvantages of the ink drawing. The black taping on transparent base foils, red and blue taping, and the block taping on diazofilms and cut and strip artwork. These are the different drawing techniques for the designing of the artwork. Before going to the layout, this is one method to design the artwork. In the ink drawing, we draw the light and make the grids. In the space of the grids, we use the inks to fill those inks, and the block taping and the transparent base foils, wherever we having that, we use the black taping. And in the here we having the two types of pads are there, that is the transferable pads and the self pads are there. By using these two, we can make the artwork. Red and blue taping, these type of red and blue tapings are used for the two sides PCB design. The red is a one side, blue is another side. The common lines are made by the black taping. Another one is the black tapping on the laser films we are using. The last one is the cut and strip artwork. So these are the different artworks we are used for preparing the layout. So in the next class, we are trying to discuss about the how we can prepare the layout preparation, and how we can manufacture, how we can get the PCB in the next class. In the next class, we are going to discuss about the layout planning. In the layout planning, how the grid system we are going to use, and the general artwork rules we are going to discuss, and different rules we try to discuss in the conductor routing, and so all we are try to discuss in the next class. Thank you.